Let's take a look at day 3 homework. We'll go over the answers. If you don't want to listen to my voice, you can just pause it and correct from what you see. But I'm going to read the name of the ion and I'm going to read the chemical formula. Uranium 6 oxide is UO3. Lead 4 chloride is PbCl4. Manganese 3 fluoride is MnF3. Ferric selenide is Fe2Se3. Copper 1 sulfide, Cu2S. Tin 2 iodide, SnI2. Stannous iodide, stannous is short for tin as well, so this is also tin 2 iodide, SnI2. Mercury 1 fluoride, HgI. Going the other way. SnO2 is tin 4 oxide. Sb2S3, antimony 3 sulfide. HGS, mercury 2 sulfide. MoCl2, molybdenum, I don't know how to say that word, 2 chloride. FeSe, iron 2 selenide. Hg2F2, mercury 1 fluoride. Fe2O5, vanadium 5 oxide. TiO2, titanium 4 oxide. Naming molecular compounds. Now, these guys are all on this sheet of common names. All right, so sucrose is C12H22O11. Sulfur is S8. It's polyatomic. Methanol is CH3OH. Now, you may wonder why they don't combine these two like CH4O. Because this is structured in a certain way, and this tells us about the structure of this molecule. CH4 is methane, HCl is hydrochloric acid, H2O is water. Naming simple ionic compounds. Again, you can pause this and just look at it if you want, but we'll go through it. Potassium chloride, KCl. Sodium sulfide, Na2S. Zinc sulfide, ZNS. Cadmium hydride. Hydrogen can either be a +1 or a 1-. CdH2, strontium phosphide, Sr3P2. CD3P2, cadmium phosphide, RbCl, rubidium chloride, SRS, strontium sulfide, AlN, aluminum nitride, Li2O, lithium oxide. Okay. Now let's look at balancing chemical equations from words. So you should be able to take and use words to write out a chemical reaction. So the first off, ammonia is NH3, and it's a gas, so we put a little G by it. Plus, solid iodine is just I. Well, iodine always comes in pairs, I2. That's a solid. To form solid nitrogen triiodide, Ni3, that's a solid, plus H2, that's a gas. So you should be able to write that out, and then you should be able to balance it. Hopefully this works. N's are balanced. We do H's last, because H is alone. I's, we've got 2 I's, 3 I's. That means we got to get these to 6. Means I want a 3 here and a 2 here. But now my N's are off, so I put a 2 here. So now my N's are good, my I's are good. Let's just deal with H's. There's 6 H's here. There's only 2 H's here. We need a 3 here. There you go. This is a single replacement reaction. The iodine replaces the hydrogen. All right, the complete combustion of propane gas. Propane. I don't know if we have propane on our chart. We've done this reaction before, though. Propane is C3H8. It's It's not on this chart. It's not here. But trust me, propane C3H8. To do a combustion, we add, so this is a gas. We add this to O2, which is also a gas. And we are going to get water. And this water is going to be a gas too, and carbon dioxide. That's also going to be a gas. A lot of gases going on here. So balance. 3 C's, 1 C. So we need 3 there. 8 H's, 2 H's. So we need a 4 there. O's, 2 O's on this side, 4 and 6. 3 times 2 is 6, and 4 is 10 O's. So we need a 5 there, 1 there. That's it. I think we've even done the second one. Propane gas, C3H8 gas plus O2 gas. It's going to give us H2O, and that's usually comes out in a gaseous form, plus carbon monoxide in a gaseous form. We did this one before. Or maybe we'll do this one in the future. I don't know which order you're doing these in. So C is not balanced. So I'm going to put a 3 here. I'm going to put it small for now because we might have to erase it. H is 8. I need that many. Now let's do the O's. Now I have 4 O's and 3 O's. That's 7 O's. Can I get this guy to 7 O's? Well, what times 2 gives me 7? 3.5. So 1, 3.5, 4, and 3. But we can't have decimals. So all we do is we double everything to become 2, 7, 8, 6. We can erase these guys. And there we go. Now it's balanced. All right, last one. The reaction of a solution of nitric acid. You can find nitric acid on here. Nitric acid, HNO3. It's a solution of nitric acid, so it's HNO3. It's in solution, so it's aqueous. Solid potassium. Potassium is just K, and it's solid. It's by itself. Oh, it's potassium hydroxide. Oh, boy. Let's rewrite this out. HNO3, aqueous, plus potassium hydroxide, solid. Now, we need to make sure that this is balanced ionically. So, OH, hydroxide, has a 1 minus charge on it, and potassium has a 1 plus charge on it. So this is good. 1 plus, 1 minus. I'm just going to write that here. So it's balanced. So this is going to form potassium hydroxide and water. So we're going to get potassium hydroxide. So that's K. Who? This doesn't work out. The nitric acid with solid potassium hydroxide to get aqueous potassium hydroxide and water. But what on earth is happening to this nitrogen? I don't know. There's a problem with this one. Let's cancel this one out because there's a problem with it. All right, so there you have it. There's day 3 homework.